Hey everyone, we're going to talk about transformations today. It's going to be a little bit different because we're going to talk about what to do when they just tell us stuff in words. So let's kind of review transformations really quickly. So remember, if it's inside, it affects x. And if it's outside, it affects y. And remember, when it affects x, it's going to affect it going left and right. And then when it's outside and affects y, it's like an up-down movement, a vertical movement, okay? So, and remember, sometimes when it's inside, sometimes it's the opposite than you would think. Because the original formula has a minus in it. Y equals a x minus h squared plus k. Okay? There it is. Transformations. It says, let the graph of g be a reflection in the horizontal and a shift of 5 units up of the graph of f of x equals x squared. Write the equation for g. So we're going to take this equation right here and we're going to write a new one, and we're going to call it g of x. So let's go ahead and write down g of x equals. So I'm noticing a couple of things. Reflection in the horizontal, or this is usually said with respect to the x-axis. Remember, if we're having a reflection with respect to the x-axis, I'm going to draw a little picture over here. You don't have to write it down. If we're reflecting like this, our up-down is moving, correct? Because I'm reflecting over the x-axis. So if it's up-down, it's affecting your y. And if it's affecting your y, this goes on the outside. So automatically we've got a minus x squared just for that. But then it also says shift of 5 units up. If I'm going up 5 units, that's affecting my y value. If it's affecting my y value, it's going to be on the outside. So this would be negative x squared plus 5. That would be your new function for g. Remember, if I go too fast, you can always pause it, and you can also go back and you can rewatch. Let the graph of g be a shift 3 units to the right and 8 units down of the graph of f of x equals x squared. Write the equation for g. So g of x equals, we went 3 units to the right. If we're moving to the right, that affects our x value. And remember, it's always the opposite than you would think. So this would be inside. Remember, x is inside. So x, now if it's moving to the right, you think it'd be plus 3, but it's actually minus 3. Don't forget your square, because we're still talking about x squared. And then 8 units down. So minus 8, because this affects the y, so it goes outside. Y is up, down. Okay? There's your new equation. Let the graph of g be a reflection of the horizontal. Now, this is also called with respect to the x-axis. Okay? A shift of 6 units to the right and 5 units down. So this is the first time we've got 3 things going on, but we can handle this totally. If it's a reflection over the horizontal, remember, that would be reflecting like this, right? That's a reflection over the horizontal. That's your y value that's moving. So if it's y, it's going to go outside. Okay, so we've got a negative here. 6 units to the right. So if I'm moving to the right, this affects your x value, which goes inside. And remember, when it's inside, it's going to be the opposite than you think. So 6 units to the right, you would think be plus 6, but it's actually x minus 6. Now notice that I put parentheses around this because this negative needs to be on the outside. 5 units down, if we're moving downward, this affects our y value, which is going to be outside of our equation. So this is going to be minus 5. Feeling good? Let's keep it going. Shift of 3 to the right. So left, right affects x, and it's the opposite than you would think. So 3 to the right would actually be minus 3. A vertical stretch of 12. Vertical stretch. So we're stretching it this way. That's up, down. That affects your y, so it goes on the outside. Right there. And a shift up of 11. So if it's going up, that's affecting your y. It goes on the outside too. Remember, if I'm going too fast, you can rewind and you can rewatch. Give the equation of the parabola based on where its new vertex is located. So if we have y equals A, x minus h squared plus k, remember your vertex is h comma k. So if we look at this graph, our vertex is at 3, 1. 3, 1. I also want to point out something about A. Right now on these graphs, you don't have to worry about finding if it's being vertically stretched or compressed. We're not going to be that crazy to you. But you do have to ask yourself if it's opening up and down. So if it opens up here, then that means there's no negative in the front, right? That's the normal way that it opens. It's positive A, then it opens up. So we're just going to leave that, and don't worry about plugging in a number for A. We're just going to leave it. So this is going to be x minus 3 squared plus 1. Totally pulling my h and k values from here. All right, let's keep going. Example 6. Again, it's opening up. So this is going to be an A value that's positive. And we're not going to worry about specifically what A is. But we are going to worry about our vertex. 1, 2, 3, 4, 5, 6, 7. So it looks like to me it's negative 7 comma 1, 2, 3. Sometimes it's hard to tell. So this is going to be our h and our k. So if y equals A, x minus h squared plus k, we know it's going to be A that's positive, so we'll just leave that alone. And then we're going to plug in our h. Now be careful, x minus, you're substituting in negative 7 for your h. Okay? And then this is going to be plus 3. Now you're going to clean that up. You know that two negatives make a positive, and then you're done. And you're smart enough now, you have got the skills that you need to make sure this answer makes sense. Look, that means move to the left 7 and down 3. It looks like we moved to the left 7 and down 3. So boom, you know you got it right. And that concludes the lesson. I hope that you had a fantastic time.